to go about getting that answer slightly differently. So let's redo the last problem we just did from start to finish using now rejection regions. So we're going to start off the same way by starting out with the claim. And the claim was, the claim was that the percentage or proportion of people who believe that they voted for the winning candidate is equal to 43%. So we'll start out with our claim. And again, remember, just like before, we got to choose between P, U, and sigma, and then which inequality we're going to use. And then our value. We'll start off there. Well, we're talking about a percentage or a proportion, so that means we're going to be starting out with a P, and then they say is equal to, so we're going to be using the equal to as our inequality or equality value. And then what value are we going to use? We're going to be talking about the 43%, which as a decimal to actually use the value is 0.43. So far, nothing different. The question is, where will this fit as our H0, our null hypothesis, or our H1? Remember, because it does have an equal to, that does mean because of the equal to that we will land in the null hypothesis, the H0. And just like before, I'm going to put a little C next to it so they know that that's the claim. That means the alternative hypothesis, which is the complement, is going to be the reverse, that P does not equal 0.43. And that at least gets us set up for our hypothesis testing, just like before. Now, just like before, we'd run our calculator test, the 1 prop z int, because we're testing a proportion. So 1 prop int test, because we're doing a hypothesis test. Int is only used if we're doing a confidence interval. And we start with our P0. It'll ask for an X, an N, and with our proportion, they want our symbol not equal to, less than, or greater than, and then we'll have our option to calculate. And just like before, remember to get to the 1 prop z test, you press the stat key, and then arrow over to the right twice to tests. And then you want to go down, I think it's option number 5, is the 1 prop z test. Now remember, the P0 or P0 comes from the H0 or H0, which means I need that probability or percentage, which is 0.43. So go ahead and enter that in as 0.43. Remember, our X and N is based on our P hat, which means our proportion from our sample, which is the 308 out of 611. So our P hat, which is our X over our N, is our 308 over 611, just like before. So the 308 goes in as our X, and our 611 goes in as our N. And then remember, this last option comes from your H1, and what symbol is always in your H1? Well, in this H1, we have a not equal to symbol, so we're going to select the not equal to option, which means that it will automatically do something that is two-tailed. And then we'll go down to the bottom and press calculate in our calculator. Okay, so then once we do that and we actually go into our calculator, it should look just like this. Except for this time, once we actually go down and press calculate, what's going to come out, the part that we're actually going to use this time instead of the p-value, is now going to be the z-value. That's going to be the 3.699, which is going to round to 3.70. That is what is called our test statistic. Remember, we're doing rejection regions now, so we're going to use the t-value. And this is our test statistic. The question is this test statistic going to be in the rejection region? Is z in the rejection region? So in order to make the rejection region, I need to draw a picture. We're dealing with z, so I'm drawing a normal distribution. But because our H1, as a reminder, had a not equal to, the picture I should be drawing is two-tailed. So I should have two tails if I am dealing with the not equal to. So I'm going to have two tails here, one on the right and one on the left. The question is, how do I come up with my rejection region? Well, as a reminder, your alpha, your level of significance, is the area in the tail, or in this case, tails for the rejection region. So if you go back to the original problem, we want to figure out what our alpha is, our level of significance, which was 0.01. The problem with our alpha being 0.01 is that's the area in both tails. So the question is, what's going to be the area in each tail individually is going to actually be half of that. So 0.01 divided by 2, which is actually going to be even smaller. 0.005 is what's going to be in each single tail by itself. Now, what's cool about these z-values is remember that z-values, whenever you have the standard normal curve, is symmetric, meaning whatever value we get down here is going to be the same as whatever's up in here. It's just one will be positive and one will be negative, because remember, with the normal distribution curve, if I could draw a little bit better, 0 goes in the middle. So we're going to have our negative z-value down here and the same value up here, but positive. That's what's going to make up our rejection region. So how do we find those z-values? Well, this means we only need to find one of the two. The easiest one to find is going to be the one on the left, because the normal distribution curve works with areas to the left, which we already have the area to the left. It is this 0.005. How do I find the z-value when I already have the area? This is what we did back in chapter 6, I believe. To find the z-value when you already have an area to the left, you're going to use the inverse norm function. And again, the area to the left of this left tail is 0.005. So you'll go ahead and go to your inverse norm in your calculator and type in 0.005. And what you'll get is a negative 2.576. And that's what we expected. So that's the value that we're going to get on this left tail, negative 2.576. What that also means is the positive tail for the rejection region is going to be the same value but positive 2.576, because it's symmetric. So those are the two values that make up your rejection region. Now, if you forgot how to get to this inverse norm, remember you go to your second key, then your distribution or vars key, and it should be the third or fourth option down. So just to kind of clarify and what our picture looks like for our rejection region, this will be a little bit nicer, is we have our negative 2.576 on one end and the positive 2.576 on the other end. So anything that falls in the two shaded regions is what's considered our rejection region, and it would get rejected if it falls in that region. Well, what are we worried about falling in this region is, remember, our test statistic that came out of our calculator. Remember, our test statistic, our z-value from our calculator, if you go back, was z equals 3.70. So if we look at our picture where our test statistic is, it would fall in this right tail down here because it is in the rejection region. Notice it is in the shaded part, so it is in the rejection region. What does that mean? So Z is in the rejection region. Remember, if something is in the rejection region, it means we reject H naught. Well, the question is, what does that actually mean? We have to figure that out. So we are rejecting H naught. And so what we're going to do is repeat what our H naught is and our H1 is and label our claim to figure out what this means. Remember, our H naught was P equals 0.43, and that was indeed our claim. And then our H1 was that P does not equal 0.43. And so what we are going to look at, and the one that we care about here, is the one that is our claim, which is our H naught, which is, according to this, we are going to reject that. So we're going to reject H naught. Notice, had H1 been the claim, we would have done the reverse. We would have accepted it. But we're not. We're on H naught, which is where our claim is, which is where we're going to reject. So we're not failing to do something. We are actually doing something. So we're going to say there is sufficient evidence. Because we're going to do something. We are going to say there is enough evidence. 2, what are we doing? Well, according to this, we are going to reject the claim. So there is sufficient evidence to reject the claim. Notice we got the exact same answer we did using the p-values. We're just using rejection regions. And I would say probably a good 60 to 70% of the test is actually the same. It's just how you're coming up with your final answer. So in every section in Chapter 8, we're going to be doing all of our problems using 2 methods: critical values and rejection regions. So make sure that you are giving yourself enough time to go through these. It takes a long time to make sure that you've got the ideas and that you have the terminology down. The calculator does most of the heavy lifting for us, but not all of it.